Imagine a telecom network that adjusts itself during rush hour, fixes broken equipment before your service ever drops, or even manages the airwaves dynamically when they get crowded all on its own, with almost no human help. That's not science fiction. That's the promise of Agentic AI in telecommunications. We're not just talking about smart algorithms that react to problems. We're talking about AI agents that can perceive what's happening, decide on a course of action, and then act on it, sometimes even before a problem starts. They're working to keep our networks healthy, efficient, and super reliable. Today, we're going to dig into what Agentic AI really means for telecom. We'll look at how companies like Trident and Ericsson are building these systems right now, what the massive advantages are, what risks we need to watch out for, and what this all means for the network operators, the engineers, and for you, the user, in the next few years. So, to start, what exactly is Agentic AI in a telecom network? Think of it as a team of autonomous AI agents. These agents can monitor the network, reason about what they see, plan a response, and then execute that plan, often in real time, with very little human supervision. They don't just recognize patterns, they make and execute decisions. These agents can handle a huge range of tasks, routing your data traffic more efficiently, allocating resources where they're needed most, predicting when a piece of equipment might fail, managing the radio spectrum, detecting faults, and even automating customer support. Now, traditional automation in telecom usually relies on rules designed by humans or requires manual intervention when something unexpected happens. Agentic AI is a huge leap forward. It learns from experience, it adapts, and it can orchestrate a whole team of other agents to work towards a high-level goal, what the industry calls an intent. Let's ground this with some real-world examples. The tech company Trident has been talking a lot about how Agentic AI can create self-optimizing networks. For instance, an agent could predict that a specific area is about to get congested, maybe a big concert is starting, and proactively reallocate bandwidth to that area to make sure everyone stays connected and without a slowdown. Trident also highlights predictive maintenance. Agents can constantly monitor performance data and even environmental stress on network equipment. By spotting faint patterns that signal a future failure, they can schedule maintenance before anything actually breaks, preventing outages. They also use agents for things like real-time fraud detection and even dynamic pricing. Then you have a giant like Ericsson. They've partnered with AWS to build what they call cognitive network solutions. Their goal is to create autonomous networks driven by high-level intent. They're using generative AI agents and something called RAPs, that's RAN, or Radio Access Network, apps, that all work together to optimize performance, cost, and the user experience. In one fascinating project, Ericsson and Telenor co-created an Agentic AI system specifically for the Radio Access Network. Its job was to optimize both network capacity and power usage. In simulations, this system achieved up to a 4% energy savings in the radio units. That might not sound like a lot, but when you scale it across a national network, the savings are massive. Ericsson is even developing a telco Agentic AI studio and what they call worker agents. These are AIs that can build and deploy other specialized AI agents for all sorts of tasks across the telecom business, from managing network settings to configuring new products. So, how does all this magic actually work? There are a few key features. First is something called intent-based control. Instead of telling the network how to do something step by step, the operator just defines what they want. For example, maintain 99.99% uptime, or reduce energy consumption by 10%. The Agentic AI system then figures out the best way to achieve that goal through its own decision-making loops. This is a core part of what Ericsson is doing with AWS. Second, these aren't single, monolithic AI systems. They are multi-agent ecosystems. You have different, specialized agents for different domains. One agent might manage the radio spectrum, another focuses on energy efficiency, a third watches for faults, and a fourth manages customer traffic. These agents communicate and coordinate with each other to make sure their actions don't conflict. Third, to act autonomously, these agents need a constant stream of real-time data and observability. They need to know everything about traffic loads, network performance, and even user behavior. They operate in a continuous feedback loop, observe the data, analyze it, decide on an action, act, and then observe the results of that action. This is what the industry calls closed-loop control. And finally, you don't just unleash these powerful agents on a live network. They are trained and tested extensively in simulated environments. That project between Ericsson and Telenor, for instance, trained their REN agent using real network data but inside a safe, simulated world to ensure its behavior was predictable and safe before deployment. So, what are the big advantages of bringing Agentic AI into our telecom networks? The most obvious is a massive boost in operational efficiency and cost reduction. With fewer manual tasks, fewer unplanned outages, and better energy management, operators can save a lot of money. We already saw Ericsson's energy savings, and Triton's points to significant cost reductions across network operations. Next is improved reliability and a better quality of experience for all of us. Networks can handle sudden traffic surges much more gracefully, reduce congestion before we even notice it, and maintain consistent service levels. Then there's scalability. As networks get more and more complex with 5G, the Internet of Things, and edge computing, it's becoming impossible for humans to manage everything. Agentic AI can scale effortlessly across millions of devices, cell towers, and edge nodes. They also offer much faster reaction and adaptation. An AI agent can adapt in real time to changing conditions, whether it's a sudden shift in data traffic, an equipment failure, or even changing weather conditions affecting radio signals. And of course, there's sustainability. Reducing power consumption in radio units and data centers isn't just good for the bottom line, it's good for the planet. But, of course, it's not all smooth sailing. Deploying Agentic AI in something as critical as a national telecom network comes with some serious challenges and risks. The biggest one is trust, safety, and explainability. If an autonomous agent makes a decision, especially one that goes wrong, operators need to understand why it made that choice. We can't have black box AIs running critical infrastructure. The system is also only as good as the data it receives. If the telemetry data is noisy, out of date, or worse, compromised, the AI's decisions could be wrong and potentially harmful. There's also the sheer complexity of integration. Telecom networks are a tangled web of different vendors, legacy systems, and strict regulations. Integrating Agentic AI into this environment without breaking something is incredibly difficult. And what about the humans? Even in a highly autonomous network, you still need human oversight. The challenge is defining the right balance. When should a human step in? How do you set safe boundaries for the AI? Security is another major concern. The autonomous agents themselves could become targets for attack. A malicious actor could try to hijack an agent or feed it false data to trick it into causing a network failure. Finally, there's the cost. The initial investment in training, simulation, and upgrading the infrastructure to support these systems can be very high. Operators need to be sure that the long-term savings will justify that upfront spend. So, as this technology develops, what are the key things to watch for? Keep an eye on case studies like the Telenor and Ericsson proof of concept for RAN optimization. Pay attention to collaborations like Ericsson and Oz, which are pushing intent-based control into the mainstream. And watch for how existing AI tools, like Ericsson's Net Cloud Assistant, get upgraded to handle more complex tasks autonomously. So what does this all mean for the people involved? For telecom engineers, your job is changing. You'll need new skills in AI, machine learning, and designing these agent-based systems. You'll become the architects and guardians of these autonomous networks. For the telecom providers, this means investing in new infrastructure and partnering with AI specialists. It also means working closely with regulators to ensure everything they build is compliant, safe, and secure. And for us, the users, the upside is better, more reliable service with fewer interruptions. The cost savings might even lead to cheaper plans. But we also need to think about trust and privacy. We should expect transparency about how and when AI is making decisions that affect our connectivity. Looking ahead, Agentic AI is pushing telecom networks towards what the TM Forum calls levels of autonomy. The goal is to reach level 4, which is fully autonomous operation under human oversight, and eventually level 5, which is end-to-end autonomy without any human intervention. We're going to see stronger adoption of intent-based networks, where operators just state their goals. We'll see more AI agents running at the edge of the network for faster, real-time decisions. And we will absolutely see a huge focus on making this AI explainable and safe to meet both regulatory and operational demands. Agentic AI in telecom isn't some distant future dream, it's happening now, in labs, in pilot projects, and increasingly, in live networks. The promise is huge: networks that are more reliable, more efficient, and more adaptable. But getting there requires a careful, collaborative effort to navigate the challenges of complexity, security, and trust. If we get it right, Agentic AI could be the true backbone of our next generation of connectivity. Thanks for watching. If you found this video helpful, please give it a like and subscribe for more deep dives into the future of technology. And let me know in the comments which application of Agentic AI and telecom excites you the most. Is it the self-optimizing networks, predictive maintenance, or something else entirely? I'd love to hear your thoughts. See you in the next one.